when it comes to this thing I've been building now. I'm provisionally going to call this service Sextant. And Sextant is because it's a tool that helps you chart your way through difficult waters and difficult application flows. What we're going to do is we're going to build a webhook service. And this webhook service is going to it's going to do a couple of things. First, an external webhook from a payment service is going to talk to our server. So it's going to talk to a Lambda here. And then that Lambda is going to update our database. So let's call this the create payment webhook. So what happens here is this is going to trigger an event to the Lambda. That is going to report payment created. The Lambda is going to update the database and say create the payment in the database. Then the database is going to come back to the Lambda and say payment created. Okay, feels good. There's something else we need to take into account, which is that there's also the update payment webhook. Let's add that. So the webhook again, report payment updated, Lambda goes to the database, update payment, and the database comes back to the Lambda, and let's just make this into a generic success response. Okay, that looks good. Now I'm going to go over to my VS Code because this little thing has been running on my local host, and it's spawned a function called createActor. And createActor is going to actually help me implement this functionality in my code. So I'm going to go const actor equals createActor. I'm going to say which service I'm describing, which is my webhook service. I'm going to say which kind of environment I want to represent here, which in this case is going to be the Lambda. The Lambda is the one that does all the work. And then I'm going to pass it an object. So we're going to intercept events from I don't know why that thing keeps coming up, which is the, what is it called? From environment, we want to intercept events from the webhook, and then we also want the handler to be our functionality here. The handler is an asynchronous function which takes in an event, some context, and a callback. And you can see there that this event is typed to the two events that can trigger when the Lambda is listening on the webhook. So when the webhook fires off its event to the Lambda, as we've seen here, it can either be report payment created or report payment updated. And there we go. They're actually in our code now. Report payment created, report payment updated. So what we're going to do is implement this. So we go switch event.type, and then we go case when it's the cannot type. When it's report payment created, then we want to what does happen when we do that? So report payment created, we ping over to the database and create the payments. Okay, let's do that. We're going to await context.environments.database.promise and then pass in an event that we want to trigger. Pretty cool, right? We can actually just get the other environments in this actor system from this context here and then just ping events over to them. That's a little bit of magic, but how do we actually implement it? Well, we can use this to attribute here. And this to allows you to fire events to different places. So this probably, the API of all this may change, but this is kind of where I'm going for now. So this database function is now just basically the exact same function as we have up here. So we can go async event context callback, and we want to switch on the event as well. So if it's event.type case, God, I keep doing that. Yeah, if it's, again, it's all typed to the events that the database can receive in this little flow. So we've got create payments. When it's that, we're going to await some random create payment function that we've got, not you, in our code base. And if that works, we probably want to call back with a message saying that it's worked. So call back with a type of success. So that seems pretty good. So now when I call back, when I go const event or const database event equals this, then this database event is going to be success. That doesn't seem right because sometimes the database event can fail for no reason, right? It can just do something random. So we probably need to account for that in our flow. So let's create a new duplicate one where which service were we doing? Oh yeah, the create payment one. we need to do an event where it fails. So I've just duplicated it down there. So create payment fails. So when that happens, we probably want to do two things. So first of all, we'll go like an unknown error occurred, or just unknown error. And we probably also want to tell that to our error tracker as well. So let's say we have like a something called like Bugsnag or Sentry that we're pinging events to so we know what happened. We're going to just ping across to our error tracker when it fails, and we'll go report error. Okie doke, let's go back to our code and let's implement that. So when this fails, then we need to go, we call back saying that type unknown error happened. And then what we can do is inside here is we can switch on the database event. Database event.type case, not going to do that. Okay, we'll go. If it was success, then we're not going to do anything, so we don't need to worry about that. But if it was case unknown error, then we're going to go context.environments.errortracker.promise type report error. There we go. You can see how this kind of looks quite nice, right? You're using the exact same language in your documentation as you are in your code. And if I want to implement the error handler thing, then I can just stick it in here. Async error tracker, and it's all fully typescripted, all fully auto-completed, and it works pretty nicely. The way this is working in general is that we have create actor, but we also have this database.json file, and this kind of loads in everything that we've put inside our UI here. So I've got loads and loads of these kind of different flows and different descriptions of things that can happen, and it's all fully documented and all fully tied into the code base. And the next step for me is going to be crafting these event payloads so that when you want to pass like a specific error into report error, like here for instance, then you can just go error is a string, for instance, stack is a very long string, and for instance, update payment, that probably has some typings on it as well, such as the ID. So again, that's going to be something that I focus on next. But yeah, this is kind of where I'm going, and I'm looking forward to, for instance, there's kind of the main thing I'm looking forward to is this adapter here is just written in TypeScript, and it kind of exports this create actor function. But really, you can take this information here and adapt it to anything you see fit to use it for. So it can traverse across languages. You could have a Go adapter, you can have a PHP adapter, do whatever you like. But it's so easy to monitor and kind of look at your code in this very high-level way, and also make adaptions that are that make a lot of sense. I'm really rambling here, but you can tell I'm very excited about this. So thanks for sticking with me, and thanks for hanging out on this Sunday to kind of get this thing working. I'll see you guys later.